Almost everyone knows that atomic materials possess a great deal of hidden and non-revelatory power that can perform so many unimaginable tasks which are hard for us to conceive of them. The question is, what would happen if we were somehow able to wirelessly transmit this power to spacecraft engines, and especially to that spacecraft that already has next-generation capabilities? Yes, this is a question about Musk's Starship, a spaceship that runs solely on nuclear power. Or perhaps a nuclear spaceship should be called. But how is that possible? Well, give the video a thumbs up and stay tuned to find out. Welcome to Genius's Guide, your daily dose of geniusness. With that being said, let's get into it. SpaceX founder Elon Musk announced that the company intends to launch its Starship rocket for the first time this year, and that it expects to launch at least a dozen rockets by the end of next year. The first flight into Earth orbit has a low probability of success, Musk stated in a virtual conference with members of the National Academy of Science, although Starship will be launched in January or February of this year, and multiple orbital test flights are expected to take place throughout the year. He said, "It's the biggest rocket ever designed, and we're close to our initial orbital launch." He added, "The stainless steel rocket and super heavy booster beneath it will be rapidly and fully reusable." He also called this combination the holy grail of rocketry. The spaceship is designed to transport up to 100 tons of cargo and people into space at as low a cost as a fraction of current designs. Accordingly, Space Exploration Technologies Corp. intends to use a modified version of this vehicle to return NASA astronauts to the moon as early as 2025 or later as part of NASA's Artemis program. In addition, SpaceX plans to transport hundreds of tons of supplies and people to Mars so that Musk can accomplish his goal of building an inhabited city on the Red Planet. Although SpaceX has launched the Starship several times from its assembly facilities in South Texas at an altitude of approximately 6 miles, 10 kilometers, in order to achieve the orbital flight, the company will orbit the Earth once and then ditch the spacecraft into the Pacific Ocean approximately 60 miles northwest of Kauai. Musk, who spoke for over an hour, emphasized that humanity needs a second planet because of a wide range of risks, including nuclear weapons, comets, pandemics, declining birth rates, artificial intelligence, and religious extremism. He said, "We've got sort of the candle of consciousness flickering in the darkness here." It should be noted that it is not necessary to completely reimagine the design of a Starship in order to convert it into a nuclear-powered one. It will in fact still be a 50-meter steel tube that launches on top of the Super Heavy booster, and it will use vacuum-optimized engines that are fueled by large propellant tanks, and a further set of gimbaled engines, which will allow the rocket to land on the surface, as well as flaps that will allow it to enter the Earth's atmosphere for the landing. According to the construction plans, it is believed that the rocket will be about 120 tons of dry mass, and that about 30 tons of propellant will be reserved for landing. Although it may not come as a surprise to you in the slightest that we can't just bolt on nuclear rockets to the Starship and expect everything to work immediately. It is very clear that many modifications will need to be made in order to accommodate the new propulsion system, as there will be new attachment points as well as software changes. But the most impactful change would and should have to be radiation shielding. Mr. Musk also seems to enjoy pointing out technological breakthroughs in which we are not even sure if they are technically feasible or not, like electrical propulsion for jets, neuron microchip interfaces to enhance the power of consciousness, a nuclear fusion which could be achieved if one increased the scale of the reactor, etc. As a result, scientists and creators back then imagined atomic versions of pretty much anything that had thermal potential as an extreme and interesting solution to a bunch of problems. According to the creators of the vehicles, there were many ideal vehicles powered by atomic reactors. In reality, most individuals believed that atomic power was a safe, green, and progressive source of energy long before the US dropped 2 atomic bombs on Japan. As a matter of fact, it would be very cool, and it will be so easy. Or perhaps we should say, less energy will be consumed if it is used to explore space. With recent partnership with companies like Atomos Space and Interstellar Technologies, 2 companies that are on this panel, SpaceX has reached new heights in recent years, supporting the success of the company. Instead of going through the process of designing and engineering ideas and then hiring contractors to design and build them, SpaceX consults with these companies throughout the entire project. It's no secret that the ultimate goal of Elon Musk is to colonize Mars as soon as possible. Because of this, it is difficult to envisage a feasible way to transport people to other planets without nuclear propulsion or some kind of technology that would shorten the journey until it becomes possible. Recently, a very interesting initiative has taken place in the private sector, where groups are trying to develop atomic rockets for the purpose of carrying out future plans that may allow landings on Mars. The idea, at first glance, seems simple, and it would work. A small atomic reactor would be completely and securely enclosed, which would mean that the only way for energy to escape would be through a tube. However, after splitting uranium, neutrons are able to trigger a chain reaction in which hydrogen propellant is disintegrated into immense amounts from the chain reaction. And by doing so, the thrust is carried out. And on top of that, it is somewhat like a coordinated atomic weapons response, except it comes with a limiter. On the other hand, some of the board members say the fuel they use has a less unpredictable nature, and that the actual response to the attack might not be as risky as the link with splitting weapons might suggest. As a matter of fact, SpaceX has previously made comments about how nuclear rockets could be a viable way for the company to send humans to Mars faster than they could with chemical rockets. As Musk said, nuclear propulsion systems use propellants much more efficiently than chemical rockets, but provide a low amount of thrust. He added, nuclear propulsion systems accelerate spacecraft for extended periods and can propel a Mars mission for a fraction of the propellant of high-thrust systems. Therefore, in terms of space innovation, there are numerous ways that we can use the power of atomic energy. With the use of atomic electric power, nuclear energy is transformed into electricity, which can be used to power a rocket's engine or another tech. In the process of atomic warming, reactors heat up fuels such as hydrogen, and the gases that are released in the process are then pushed out, creating atmospheric pressure. This is a lot more powerful than electric motors. According to US Rep. Ware Diva, who seats the council, said if SpaceX wants to go to Mars soon, time is of the essence. If the United States is not kidding about driving in a human mission to Mars, we have no ideal opportunity to lose. Bear added that, in the course of recent years, Congress has kept on financing atomic space innovation improvement at SpaceX, determined to direct a future in spaceflight test. Despite the fact that atomic electric impulsion has many advantages, notably when it comes to rapidly traveling to Mars, it will also have many disadvantages when it comes to its creation and application. During the consultation, Roger M. Myers, the co-chair of the Committee on Space Nuclear Propulsion Technologies, stated that the challenge with the materials would be to find or develop materials that could be open to the heat and can withstand other outrageous factors of space. Myers added, there is little doubt that the key to manned exploration of the solar system is the successful utilization of the energy locked within the uranium nucleus. Generally, Myers is right, although no official statements have been made by Musk regarding nuclear Starship. So this is just a future project that is still in the works. But what do you guys think about this? Let us know in the comment section. Make sure to hit the like button and subscribe button for us to provide you with more must-know developments in finance and technology. We'll see you soon.